Alright, what's up guys? Welcome to part 3 of this 24 well played series. In this video, I'm going to show you some other features besides design that's in Fusion 360. Now, this is pretty cool, so pay attention. And again, this is different from just designing. First thing I'm going to show you is I'm going to skip rendering because I don't really like rendering in Fusion 360. I'd rather render using Blender or any of the other million of 3D CAD rendering software out there. Fusion 360's rendering engine's okay, I just don't prefer it. Animation, however, can be very cool in Fusion 360. So here we have, let me delete that. Here we have our scene, essentially, our timeline, right? So anything you do with the record button activated, this little red thing activated, it will record what you're doing and put in a keyframe. And what that means essentially is how Fusion 360 works is it uses keyframes. So let's say you want to move from here to here. All you do is have your starting object and your end object, and Fusion 360 will automatically move that thing for you from here to there. In a nutshell, that's how it works. So let's do that. Our first keyframe is always the center of origin, right? So the first thing I want to do is slide where I want to approximately put my first video or my first keyframe, and I want it to be here. Right, so we're going to make sure we're recording. Going to go here to about, I don't know, the 5-second mark. And I'm going to move the 24 well plate so it's centered and kind of facing me. Right there, just like that. And as you could see, I now have a video clip, a little camera clip enabled. And all it's going to do is move it from its default position to wherever I ended, right? It'll automatically move that for me, right? And the reason why I'm putting it here is because the next thing I want to do is move this lid. And if you right click and hit manual explode, you could now choose to move the lid upwards by about this much. So it'll essentially separate the lid from your design, and it's going to put it here because I forgot to move my cursor, but that's perfectly fine. That's okay. I'm going to hit the OK check mark for that's what I want the animation to do, and I'm going to move the cursor to about here, and then I could drag this to where it locks here. So essentially my animation, all it's going to do is pan up a little, and then it's going to separate the lid, right? It's going to separate the lid, right? Now I want the lid completely gone. I want it out of camera. So all I'm going to do is select it, go to transform, and move it up by 65 and hit OK. Oops, I forgot to. I'm going to undo that, Control Z. I guess another way that I could do this is I could select this, right click, transform, and say that I want to move it in the Y distance by, let me move my cursor out a little first before I do that. Say I want to move it in the Y distance by about 10. Right? And all that's going to do is keep my 24 well plate, right? The lid on the 24 well plate, then help move my lid out of the way. And see how I was kind of slow there? I don't really like how it was slow, so I'm going to speed this up. So it essentially just moves my lid out of the way. Now, I'm going to put the cursor out here at the 12-second mark. And I'm going to zoom in the camera a little to about here. And you'll see why in a sec. Next thing I'm going to do is select the lid and go to right click and go to show hide, trail lines. And then I'm going to click down on the drop down, click down, and click the eye icon on the lid. So now it'll show a light bulb here indicating how far the lid is basically going to be shown. And I want it to stop showing in about here. And what you'll see is the animation is the camera will move, my lid will then pop off and then disappear. Gone. And now you have my 24 well plate. And there you go. That's just a simple, quick, easy animation. From there, I could do annotations and create callouts saying this is my first well plate, this is that, so on and so forth. You could even publish these videos straight to YouTube of just your animations. And it helps for many various projects to kind of break apart whatever you have to show people, hey, this is what I build and this is how it works, essentially. Right? That's just the animation. The other cool thing for you biotechs out there is the simulation mode. Now with simulation mode, there's a number of things you could do. Static test, which is probably the thing you're going to be using most. If you're dealing with frequencies, there's frequencies, or electronics, there's thermals and cooling, there's stress tests, there's a bunch of things you could do. I'm going to go with just a static test because I'm going to be pretty basic. And the first thing you want to do is simplify your object here, right? Now, I don't really care about my lid. It's not going to be a part of my study. It could be, but to me, it doesn't matter. So I'm going to go to simplify. Then I'm going to drop down everything, and I'm going to right click on my lid and go to remove. And that'll remove my lid and simplify my my entire simulation mode. And then I could click finish simplifying. So now I don't have to worry about the lid. If I did want to do the lid, I'd have to kind of make a contact point for the surface of the lid and the surface of this by making contact points down here. But I just want to avoid that situation because that's going to make this video longer than it should be. The next thing you're going to do is you're going to select the material, as a 24 well plate is not made of steel, which is the default setting. So I'm going to scroll down and choose plastic because that's essentially what a 24 well plate is, plastic, right? And that'll automatically make everything here plastic for my 24 well plate. From there, I'm going to have to create a constraint. Now, a constraint is basically going to hold whatever your object is in place. It's not going to move at that one location. So I'm going to click a constraint and say, I want this little edge to be constrained. Not the whole surface, but this just this little edge to be constrained. Maybe even the corners. That's what I want to be constrained. So essentially, this part of my 24 well plate isn't going to move. Everything else is. Right? I'm going to click OK. You then want to add a load. And if you want to simulate this in space, don't put on gravity. But most of the case, you want to turn on gravity. It's just a quick, easy fix. Going to help make your simulations a little better. The next thing you want to do is create a load, right? So load is, in this situation, is pressure that you're going to put on your object. I'm going to put a structural load on this side of my object. And you'll see it gives me a bunch of options to choose from, right? So I want pressure hitting the right side of my plate on this face. And I could choose how. I could choose, is it going to hit it flat? Is it going to hit it at an angle? Is it going to hit it at certain vectors? I'm just going to make sure it's normal. You could choose, do you want it to be a force? Do you want it to just be pressure? Do you want it to be momentum? A bearing load? Hydrostatic pressure? I'm just going to give it a force. And I also am going to give it 1,000 newtons of force. So this should pretty much crush my plate. If you don't know what 1,000 newtons of force is, you could always change the newtons change the units from newtons to whatever your country or whatever you're doing is comfortable with. 1,000 newtons is 200 pounds of force. So I'm hitting this plastic plate with 200 pounds of force. So let's go to 1,000 newtons. And you know what? I'm going to hit it in 1 point. Instead of just the entire surface, I'm going to hit it here at 1 point. So it's just hitting at this vector. We're going to see what it looks like, right? The next thing you want to do, once you have all your constraints, all your loads set, is you're going to go to this pre-check button and click it and make sure it says the study is set up and you have everything that you need. Yay. If you don't, let's say I forgot to put a load. I don't want to delete that because it's going to make it longer. Let's say I forgot to put a load. It'll tell me, hey, what are you doing? You only have constraints. What's your load? Why would I process this? Right? So from here, you're going to go to results and click stimulate results. It's saying, hey, this hasn't been computated yet. Would you like to run it now? Of course I want to run it now. Now you could choose to do it on the cloud. I don't like doing that because I have a beefier computer than what they have at the cloud. So I'm just going to solve it on my computer. And you'll see it's pretty much going to do it relatively quickly as opposed to doing it on the cloud. That's okay. Give it a few seconds. Should be done. Oh, dropping back a little. Surprising. Yep. So I'm going to talk a little while it's loading. So this simulation gives you an idea of the forces and stresses that are going to be exerted on your plate. As you could see, putting 1,000 pounds of force on 1 point, towards the bottom of my plate, is going to lift my plate up and pretty much hurt it at this corner, right? Because I only gave it a constraint on this side, right? Now, this is the safety factors. If I want to see the stress, all my stress is at the points where I held the plate down, right? So these corners here where I've held the plate down, that's where all the stress is going to be because I told it that's where it's not going to move. So if I apply a force here, that's essentially 1,000 pounds of force. That's essentially what's going to happen. It's going to lift my plate and kind of bend it, right? So if I look at displacement, the whole thing moves. If I do this, it's going to bend my plate up, right? If I look at my reaction forces, if I hit it, I'm going to get no newtons here, but at the corners, I'm getting 1,290 or 86 newtons of force at the corners, right? And these are, you shouldn't take them like exact values. You should take these as estimations and then go test it in real life and see how close they are, right? So yeah, that's essentially simulation mode. You can look at strain, the force, displacement, stress, which is probably the most important one, stress for biotech. Okay, so we have that simulation, right? We're finished with the results. What if we want to change this to where this whole thing is now constrained, right? So this entire surface can't move. So instead of lifting up, it shouldn't be able to lift up anymore, right? And this force, instead of being kind of down where it is, it's fine. It's about where I want it to be. But yeah, it's about where I want it to be. But instead of, let's just make it the full surface. Instead of 244 pounds of foot force, we're going to go back to newtons. And we're going to change this to 10,000 newtons. So this should pretty much crush my plate, right? Go to pre-check. We're good to go. Results. Simulate the results. It's going to say, hey, wait a minute. You made some changes, right? So if I go to solve, and solve it locally, it's gonna change my results to whatever I basically changed. And the cool thing about this software is you could have side-by-side simulations. So let's say I wanted to look at it at 1,000 Newton forces versus 10,000. It'll show you side-by-side an estimation of what's going on. And that's the strength of this software. It's pretty amazing. So let's see what 10,000 Newtons on one side of my plastic 24 well plate does. Yep, as you could tell, it demolishes it. So it essentially, because this is the only part being constrained, it essentially bends it like a deck of cards, right? That's kind of what it's showing you that it's doing. There is stress literally everywhere. All of my wells have stress. There's a stress everywhere, right? The highest stress points are inside the wells with 109 millipascals of stress, and the lowest points are about zero, about negligible, right? And that's also inside my wells, but facing on the x-axis, not on the y-axis. If I go to displacement, the whole right side is displaced. It's displaced by 17 millimeters, which is bigger than my plate. My plate only goes, 9 millimeters high? It's going to displace the entire thing. It's just going to bend it. Reaction, I pretty much just crushed this side. Everything's just being crushed on this side. My strain, all over the place. So again, very cool software to use, right? And if I had two of these, I could hit the compare function and view them side by side, right? So if this was another study, I could view it, and whatever I do to one, like rotation wise, it'll do it to the other. And yeah, just very cool software. Finish compare, finish results. And with that should pretty much do it for the 24 well plate. Please let me know if you have any questions, and I'll see you in the next one.